Hey everyone, welcome to this explainer. Today we're embarking on an absolute quest to master JavaScript numbers. We're diving straight into a definitive study guide that's going to show you exactly how to control your numerical data. Understanding how JavaScript handles numbers, that is the absolute key to writing flawless programs. So let's jump right in and decode this together. Okay, let's dive right into this. Here are the 5 modules we're going to conquer today to prevent those early stage coding bugs. 1. JavaScript numeric basics. 2. The string trap. 3. Debugging data types. 4. The math object methods. And finally 5. Advanced math tools. All right, kicking things off with Module 1, JavaScript numeric basics. Before we get into anything crazy, we absolutely have to celebrate JavaScript's incredibly simple approach to numbers. And this brilliantly illustrates why. You know, in languages like C# or Java, you have to explicitly define your numbers. You got to tell the computer, hey, this is an integer for whole numbers, or this is a float for decimals. It's a whole thing. But in JavaScript, you are completely freed from all of that. There's just one unified number type. Storing an age like 25, just write 25. A price like $19.99, just write $19.99. It's all just numbers, plain and simple. Moving right along to Module 2, the string trap. Okay, every good quest has a plot twist, right? And here's a deceptive little danger that catches almost every single beginner. I like to call it the hidden peril of quotation marks. So picture this. You've got a variable set to the number 7 and another set to 5. But that 5 is wrapped in quotes. What actually happens when you try to add them together? Do you get 12? Does the whole program just crash? No way, the answer is actually 75. Wait. What? Why? Well, it's because of a concept called concatenation. See, the second you surround a number with quotation marks, JavaScript instantly stops seeing it as a number and starts treating it as text, a string data type. And when you try to add a pure number and a string together, JavaScript won't do actual math. Instead, it literally squashes the two values side by side. It takes the 7, slaps the 5 right next to it, and boom, your final result is the string 75. So the absolute golden rule here is urgent. Never, ever surround your numbers with quotes if you actually want to do math with them. Which brings us perfectly to Module 3, debugging data types. So if strings are masquerading as numbers, how do you know if you're dealing with a pure number or a sneaky string? Well, it's time to go into detective mode. Now, what's really interesting about this is that your browser's developer console actually has built-in visual cues to help you solve this exact mystery. When you log a variable to the console, look really closely at the color. Pure numbers, they pop up in a bright blue. But if that number has been turned into a string, like that 75 we just talked about, it hides in plain sight, colored completely black. But hey, sometimes visual colors just aren't enough, right? Or maybe you're writing validation logic directly into your code itself. Well, here is your magnifying glass, the type of operator. By just writing type of, followed by your calculation, like a plus b in parentheses, JavaScript will explicitly confirm the exact data type for you. It'll literally spit back the word number or string. This is exactly how you confidently verify your results when you just can't rely on the console colors. All right, time for Module 4, the math object methods. Now it's time to seriously level up. We are unlocking JavaScript's built-in precision tools, the math object. You can kind of think of it as this superpower utility belt you can call upon anytime just by typing the keyword math with a capital M followed by a dot. For starters, we have this amazing menu of precision rounding tools we need to master: math.round, math.floor, and math.ceil. First up on the menu is math.round. Honestly, this one behaves exactly like the standard math rules you learned back in elementary school. If you pass in the value 7.5, math.round recognizes that the decimal is 0.5 or higher, and it naturally pushes that number upwards, handing you back an 8. If it was, say, 7.3, it just rounded down to a 7. Super classic, super reliable. But what if you want to completely ignore those normal rules of rounding? Enter math.floor. Let's say you pass in 7.9. It doesn't matter that 0.9 is incredibly close to 8. Math.floor is ruthless. It mercilessly forces the number downward to the nearest whole integer. The decimal is just chopped off entirely, leaving you firmly on the floor at 7. So the crucial point is, if the floor forces things down, the exact opposite is math.ceil, which is short for ceiling. If you pass 7.1 into math.ceil, it acts as a hard barrier above your number, forcing any fractional amount straight up to the next whole integer. Even though it's barely above 7, it's pushed all the way up to 8. Basically, you are in absolute, total command of the direction your numbers move.
And that leads us to our final stop, Module 5, Advanced Math Tools.
Looking way beyond just simple rounding, the math object is packed with methods that act as incredibly powerful filters. Just look at math.max. You can pass a whole bunch of multiple values right into it, say 7, 4, 9, and 8. If you're dealing with a bunch of random dynamic user inputs, math.max instantly sifts through all that noise and just plucks out the absolute highest value, in this case, 9. It completely saves you from having to write out all that complex sorting logic yourself.
And it totally doesn't stop at calculations. The math object is also basically a built-in encyclopedia for vital mathematical constants. Let's say you ever need to do geometric calculations. You absolutely do not need to sit there manually typing out pi. You just call math.pi, all caps, and JavaScript immediately hands you 3.14159, and so on. It is a massive, massive time saver.
So, to recap our amazing journey today, keep your numbers completely free of quotation marks so you don't fall into that string trap. Definitely use your console colors and the type of operator to debug your data types like an absolute pro, and always, always leverage that powerful math object for your rounding and calculations. But wait, what happens when a numeric operation fails so spectacularly that the result is technically not a number? Well, that introduces a very mysterious validation state known as NaN. But to unlock that secret, you're going to have to join me for our next explainer. Keep coding, stay curious, and I'll catch you next time.